In the vast expanse of the universe, there exists a mysterious substance that eludes direct observation. This enigmatic force, known as dark matter, remains one of the greatest unsolved mysteries of modern astrophysics. Despite its invisible nature, dark matter's presence is undeniable, shaping galaxies, clusters, and the cosmic web itself. Amidst this cosmic puzzle, our home planet Earth embarks on an intricate cosmic journey, one that intertwines with the hidden realms of dark matter. As Earth orbits the Sun, it carves a path through the vast dark matter halo enveloping our galaxy. This journey is not merely one of orbiting celestial bodies. It's a voyage through a realm rich with potential clues that could unlock the secrets of dark matter. Dark matter remains one of the most enigmatic and intriguing mysteries in the universe. Despite its name, dark matter does not emit, absorb, or reflect light, rendering it invisible to our traditional observational tools. Its presence is inferred through gravitational interactions with visible matter. This narrative delves into the captivating topic of how Earth's interaction with dark matter might leave behind subtle traces, offering cosmic clues that could ultimately unlock the secrets of this elusive substance. Unveiling the nature of dark matter. Dark matter's existence is inferred from its gravitational influence on galaxies and galaxy clusters. The amount of visible matter can't explain the observed gravitational effects, indicating the presence of an invisible, massive component, dark matter. Scientists have proposed various candidates for dark matter particles, including weakly interacting massive particles, WIMPs, and axions. Despite extensive efforts, these particles have yet to be directly detected. This lack of direct evidence challenges researchers to explore alternative methods to study dark matter. Earth's journey through the dark matter halo. Earth is not a passive observer in the cosmic dance. As our planet orbits the Sun, it plunges through a hypothetical halo of dark matter surrounding the Milky Way. This halo, a vast and diffuse cloud of dark matter particles, influences Earth's trajectory and potentially leaves detectable traces. While dark matter particles are elusive, their sheer abundance ensures that Earth frequently interacts with them. However, these interactions are incredibly subtle due to the weak nature of dark matter's interactions with regular matter. To unravel these interactions, scientists have embarked on ambitious experiments deep beneath the Earth's surface. The quest for direct detection researchers around the world are building sophisticated detectors to capture a glimpse of these elusive particles. These detectors are often located in underground laboratories to shield against interference from cosmic rays and other background radiation. They are ultra-sensitive instruments designed to pick up minuscule energy deposits that could indicate a dark matter collision. One such approach involves using liquid noble gases like xenon or argon. When a dark matter particle collides with an atom in the detector, it imparts a tiny amount of energy that triggers a detectable signal. These experiments are conducted in absolute darkness, at temperatures close to absolute zero, to minimize any potential interference. Signals from the abyss, Earth's encounter with dark matter. The hope is that one day these detectors will pick up signals that deviate from the expected background noise, indicating a rare interaction between dark matter and ordinary matter. While numerous experiments have been conducted, no definitive dark matter signal has been observed yet. This absence of detection highlights the extreme challenges of this endeavor. As Earth orbits the Milky Way, it continually samples the dark matter halo, offering a unique vantage point for potential discoveries. The periodic nature of Earth's motion introduces the possibility of observing an annual modulation in the dark matter signal, corresponding to Earth's changing velocity as it orbits the Sun. Challenges and future prospects. The search for dark matter signals is a painstaking and iterative process. The detectors must not only be incredibly sensitive, but also robust against various sources of noise and background events. Overcoming these challenges requires an ongoing collaboration between physicists, engineers, and other experts. Looking forward, the construction of larger, more sensitive detectors and advancements in detection technologies offer hope for a breakthrough. As we venture deeper into the heart of the dark matter mystery, Earth's journey through the cosmos continues to provide us with cosmic clues, that could one day unveil the nature of this invisible cosmic companion. Parallel worlds and the multiverse hypothesis. The interaction between Earth and dark matter also opens the door to intriguing possibilities related to the multiverse hypothesis. Some theories suggest that our universe is just one of many, existing alongside countless others in a vast multiverse. If this hypothesis holds true, dark matter might be our cosmic bridge to these parallel worlds. The concept proposes that dark matter could interact gravitationally with other universes, influencing their evolution and vice versa. While this idea remains speculative, it adds an additional layer of complexity to Earth's interaction with dark matter, making it a potential conduit to realities beyond our own. Cosmic archaeology, examining Earth's history through dark matter. Beyond its potential influence on the multiverse, Earth's interaction with dark matter offers a unique lens through which we can examine the planet's history. By studying the distribution and properties of dark matter particles that have interacted with Earth over billions of years, scientists can reconstruct the planet's cosmic journey. As Earth continues its orbit through the dark matter halo, it accumulates a record of its cosmic interactions. Analyzing this record might reveal valuable insights into the planet's past, including potential correlations with geological events, mass extinctions, and climate changes. Ethereal signals. The quest continues. The journey to detect dark matter signals is characterized by its ethereal nature. Researchers strive to capture elusive particles that permeate the universe but rarely interact with regular matter. This pursuit requires patience, dedication, and a deep understanding of the fundamental forces that govern the cosmos. Scientists continuously refine their techniques and technologies, seeking to increase sensitivity and reduce background noise. As experiments push the boundaries of what is technically achievable, they also expand our understanding of particle physics, materials science, and the cosmos itself. Collaboration and global efforts. The search for dark matter is a global endeavor that unites researchers from various countries and disciplines. International collaborations share knowledge, resources, and expertise to tackle the complex challenges posed by this enigmatic substance. Scientists collaborate on designing and building detectors, analyzing data, and developing new theoretical frameworks. This cooperative spirit enhances the likelihood of a breakthrough and underscores the significance of Earth's connection to dark matter on a global scale. Looking ahead, from traces to revelations. As Earth's journey through the dark matter halo continues, the quest for discovery presses forward. The dream of detecting dark matter particles might seem distant, but each step taken brings us closer to unraveling this cosmic enigma. Advancements in detector technology, increased computational power, and a deeper understanding of particle physics contribute to the optimism that one day the cosmic clues left by dark matter will lead to revelations about its nature. Earth, as a cosmic traveler and an experimental laboratory, plays a vital role in this ongoing investigation. The cosmic connection, Earth's legacy. As we ponder Earth's connection to dark matter, we recognize that this journey extends beyond the realm of science. It speaks to our innate curiosity, our desire to explore the unknown, and our aspiration to understand our place in the universe. Earth's role in the search for dark matter transcends time and borders. It becomes part of humanity's legacy, a testament to our relentless pursuit of knowledge, our unwavering dedication to discovery, and our unyielding bond with the cosmos. Earth's halo, a cosmic archive. The dark matter halo surrounding our galaxy is more than just a cosmic mist. It's a vast, invisible archive of interactions. Over eons, Earth has traversed this intangible realm, leaving behind a subtle record of its encounters with dark matter particles. These particles, despite their elusive nature, carry the potential to reveal secrets about the universe's building blocks. Scientists are investigating ways to decipher this cosmic archive. By scrutinizing the distribution, energy levels, and patterns of dark matter collisions, researchers aim to uncover subtle hints that might lead to the elusive dark matter particles. It's akin to reading cosmic hieroglyphs encoded in the fabric of space. Earth's gravitational pull, though small compared to massive cosmic structures, exerts a subtle influence on nearby dark matter. This tug creates a delicate interplay between our planet and the unseen particles that permeate space. As Earth orbits the Sun, it drags this hidden matter along, leaving behind a subtle trace of its passage. While the dark matter's response to Earth's gravitational pull is tiny, it's a testament to the interconnectedness of all cosmic entities. This interplay is an example of the intricate web woven by the universe's fundamental forces. Dark matter whispers, signals from beyond. As Earth ventures deeper into the dark matter halo, it encounters particles that rarely interact with ordinary matter. These particles, which traverse our planet without leaving any visible trace, might emit whispers that are too faint to hear directly. However, scientists have devised ingenious techniques to catch these cosmic whispers. Sophisticated detectors deep within the Earth's crust await these faint signals. These instruments, often nestled in shielded chambers to minimize interference, hold the promise of unraveling the dark matter mystery. By distinguishing the soft murmurs of dark matter from the cosmic noise, researchers aim to uncover the universe's hidden symphony. Earth's solitary quest, searching for the elusive. The quest for dark matter signals is a solitary endeavor in the quiet depths of Earth's underground laboratories. Shielded from the bustle of the world above, researchers sift through data, meticulously separating potential dark matter signals from background noise. In these serene environments, researchers confront the challenge of isolating the faintest of signals from a sea of cosmic interference. These moments of quiet introspection, coupled with the thrill of discovery, represent the culmination of humanity's thirst for understanding. Cosmic jigsaw, piecing together the puzzle. The search for dark matter signals resembles a cosmic jigsaw puzzle. Each interaction between Earth and dark matter adds a new piece to this intricate picture. The challenge lies not only in finding the pieces, but also in assembling them to reveal the complete image. As scientists analyze data from around the world, they strive to identify patterns, anomalies, and deviations from the expected. These clues offer glimpses into the hidden world of dark matter, slowly bringing the puzzle into focus. Earth's echoes in the void. A legacy unfolds the traces. Earth leaves in the dark matter. Halo are echoes in the void, a testament to the intricate dance of the cosmos. These echoes are an intangible legacy, representing humanity's relentless pursuit of understanding and our insatiable curiosity. While we may not yet have deciphered the secrets hidden within these cosmic traces, their mere existence speaks to the resilience of the human spirit. Earth's journey through the dark matter halo symbolizes our enduring quest to unveil the universe's deepest mysteries, reminding us that as long as the cosmos beckons, we will continue to explore, inquire, and dream. As we conclude our exploration of Earth's cosmic connection to dark matter, we're left with a sense of awe and wonder at the intricate dance between our planet and the hidden forces of the universe. The journey through the dark matter halo is a journey into the heart of the unknown, a quest for answers that spans continents, disciplines, and generations. Just as Earth navigates its path through the cosmos, so too do we navigate our journey of discovery. The pursuit of understanding, the quest for knowledge, and the yearning to unravel the mysteries of dark matter are endeavors that unite us as curious beings. Our shared fascination with the universe binds us together in this cosmic journey. If you found this exploration of Earth's cosmic connection to dark matter intriguing and thought-provoking, we invite you to join us on this ongoing adventure. By hitting the like button and subscribing to our channel, you become part of a community of thinkers, dreamers, and seekers of truth.